Welcome, everybody. Tonight we're working on Unit 16, which is the last and final unit of this course. And we're going to talk about basically the future of machine learning and deep learning and some key technologies. Just got to make sure I'm clicking on my screen here so I can advance my slides. These are the topics for the night. We're going to talk about AutoML, AutoGPT, TinyML, and ML operations relative to like teamwork and the impacts of all these technologies. We'll also get to play a little bit with an AI agent and talk about what that is. Let's get started. So the first technology we're looking at is technology called AutoML, right? Which implies that it's got some level of automation to it, and it's precisely the point. And they asked this question to start with, which is, why do we even need this, right? And what they're showing here are some of the steps that we get into when we're doing machine learning, right? So you get information, you prepare it, select the model, train the model, evaluate it, tune the parameters, and then get predictions. And hopefully once your model is all fleshed out, then you can actually use it to do productive work, right? It doesn't just automatically happen. And this is, as it says, a generic representation, but the process kind of mimics, the project life cycle, right? But it also has its own approach. And now that we've learned really truly what machine learning is, you'll recognize all of these steps and why they're important. All the steps are important, and we've worked on every aspect of this at this point. The point that they're trying to make here is that for a lot of organizations, that it's actually kind of difficult to get all this stuff in place because it takes so much time to figure this stuff out. So like usually what a company will do is hire somebody that already knows what's going on rather than take people internally and train them, because that takes a long time. And then even after they're trained, you can imagine this is pretty technical work. The math is heavy. If you don't have experience with it, it takes a while to choose the right models and train them, and et cetera, et cetera. And so the point of this technology is to automate some of these tasks and hopefully to make the whole process just basically a little bit better and easier without a lot of intervention. One of the goals of this technology is to basically put automation into all the stuff that is time consuming, right? Like, which algorithm should I use? Okay, what should the code look like? And then where's my data coming from and going to? And then when we're running the models, how do we tweak it to adjust it to make it better, right? So that's what we're trying to kind of automate, right? Are some of those steps. What's really cool about this technology is all the key algorithms are basically built into it. Like all the stuff that we learned in this class, like random forest, nearest neighbor, the K thing, SVMs, et cetera, they're all kind of already present within the technology. And then you can cherry pick the ones you want to use. It says it performs data pre-processing, like if you're missing values, it'll fill them in, or it'll scale out the features, or select which features are relevant, all that stuff that we talked about. It also helps to do the tuning, right? So when you're tuning the parameters of the models, it aids with that step. And then it also automatically decides or tries different ways to put the algorithms together that would make sense for the situation you're dealing with. So it's kind of taking some of the human guessing out of it. So you see the advantage and the beauty of this, right? It's attempting to make it simpler. So here it says, how does it work? Basically, you still have to start with a data set, right? The data set's got to be a good data set, and it's got to be large enough and robust enough and all that to be able to do the stuff that we need to do. And I think what we've learned in this class is you can use very simplistic data sets and get very simplistic results, but really to get good machine learning models, the more data we can throw at it, the better, right? Because we have to train it, then we have to test it, right? And then we have to revise it. All that stuff takes a lot of data. The data set should particularly include a target variable as well as any other data that we can use to predict stuff. Okay, um, so what they're really saying here, just overall, the data is important, and the technology also helps to figure out pretty quickly what data is really relevant and what data is basically not. Um, so basically, when we start to use this technology, you have to specify what your target column is. Are you like, I don't know, trying to maximize profit or minimize scrap, or what is your goal? And it basically it says here the second bullet, AutoML produces a data profile similar to the outcome of an EDA. Do you guys remember what an EDA is? The acronym? Yeah, you can Google it, but it's an acronym for exploratory data analysis, which means exactly what it sounds like, that you have to, like, basically, as a human, right, if you're processing data, you got to look at the data and see what it is, right? What does it look like? How complete is it? Is it quality? What do these numbers mean? All that stuff. And AutoML kind of handles that piece. It makes that analysis for you. It'll also focus a lot on some of the essentials of data, right? Like the mean, the median, the quartiles, the data profile, all the statistical pieces that go with data. And then it also figures out if certain variables are numeric, like, I don't know, like a grade or a score or something like that, or if it's a category, like yes, no, or maybe a gender specification or some other categorical data, like never, sometimes, always, definitely, that kind of stuff. So it can handle both types, basically. It does work really well when the data is highly structured. Everything's labeled, it's well formatted, and it can sort of handle some anomalies, right, by filling in the blanks on its own, by looking at the other parts of the data, right? So like if you're missing a piece of data, it might be able to extrapolate it. And AutoML basically is really useful if you want to make a quick assessment of the model that's being tested, right? So like, hey, should we use this model or should we use that model, right? And that'll give you somewhat of a quick analysis, and that speed is really pretty important. When do you want to, like, not use it? If your data set is very small, and they even go up to medium-sized data sets. I'm not sure what that means exactly, but if you use the small ones, it says you're going to be trained quicker compared to larger data sets. But it can be quite expensive to run it with large data sets. So this is one reason why it might not be a great idea, right? It can also be kind of slow because it tunes itself. So that way, if you're paying for that processing power, let's say in the cloud, that becomes very expensive, right? And so AutoML in some cases might be better off done locally, right? So there are some popular ones out there that people use. Here's one called AutoGluon, and I think we brushed upon this in the first class. And notice that this is an open source thing. It was developed by Amazon. That's AWS, by the way. And it works really well on text, image, and tabular data. Tabular data is like spreadsheet data or CSV files, for example. Look at the platforms it runs on, though. This is intended for Linux platforms, really, and as a result, also runs on a Mac, but not really supported for Windows. So, like, you got to be a Linux person to run this, or a Mac person. So, interesting. Now, that should never scare you as an IT person. It is possible to spin up virtual machines of Linux right on your own computer. You can have dedicated machines that do it, or if you happen to have a Mac, you can do it on a Mac. Another one is MLOps, and I don't know if you guys are picking up on, like, the dates that these tools were introduced. right? So this stuff is not like completely brand new. It's been around for a little bit. And basically what this one does, they call it the machine learning box. It's a powerful library. It says three sub packages that do pre-processing, right, to read and pre-process data, optimization to test or optimize the models, and then prediction to predict outcomes on test data, right? So it does all three of those things. And it says it can perform feature selection, parameter tuning, model selection for classification and regression. Those are the typical ones, and predict target variables. So it kind of does a lot of what we just talked about, right? All in one thing. This is, I believe, multi-platform. The scikit-learn library also has this tool called Auto sklearn. And this is, probably the one that we're thinking of as, we call it AutoML. It comes from this core library. We've used aspects of these libraries over and over again in this class. Algorithm selection, parameter tuning are all automated. It only supports sklearn based models. Basically, it's not good for graphical models or sequence related problems, right? But for the other types, it would work well. All right, now we're going to start talking about this thing called AutoGPT, right? Which gets us more into the generative AI area. And I think this gets kind of interesting. They make a point here of talking about ChatGPT because that's kind of like the preeminent product still. And the remarkable thing about working with ChatGPT is it's language based. So we like ask it a question verbally or type it in, and it reads that, understands it, and then generates content, right? But it says it does have some limitations and how this new concept of auto GPT, and it's not, once again, not super new, but it's finally taking off, by the way, and how that plans to fix it. All right, so here's the prompt. It's basically, imagine a breakthrough technology that enables language models like ChatGPT to go beyond single task completion and handle more complex instructions seamlessly. Okay, so I've actually demonstrated some of this in class before with a different like auto GPT kind of tool. And I was kind of floored by it, right? Because this is the Chinese one called Manus, MANUS. And, I would ask it a prompt, and like most, AI engines, you give it a prompt and it generates something and you go, okay, can you also do this to it? And can you tweak that? And then how do I fix this? And then what, you end up asking like 10 questions, or something like that to really get what you want, and that's not unusual unless your initial prompt was perfect, right? And let's face it, how many of us do that? Very few of us. So let's look at what this does. Right. So a couple of definitions here to start with. Since we are moving into the natural language processing, this is kind of the realm we're moving into, right? So we're looking at large language models, and it's basically a machine learning model. So it's still machine learning, but it's used to generate text instead of like calculations, for example. OpenAI's GPT, right, the one that drives ChatGPT, is the most popular out there. There's version 4 out there, and I don't know what the sub numbers are right now. And the older versions are still out there. And most of the time when we're using the free versions, we're tending to use the older versions, by the way. And you can downgrade, and that's the thing you can do. Like, depending on what tool you're using to get to your AI engine, you can always downgrade the model you're using and get a little more out of it.
Currently, ChatGPT is on 4.5, but if you're using it for story writing, like I'll do for tabletop RPGs, 3.5 is a far better English writer. 4.5 and 4.0 tend to be a little bit better at programming.
Okay, and thank you for sharing that, and I appreciate the insight. I don't pay for the models, so I'm always like stuck on the free side of things, but I am thinking about changing that approach. Okay, so chatting is a workflow where you prompt the AI and it returns a text response. I guess we get that one. And OpenAI's ChatGPT is a web application, right? And I think we've all tried the tool, and I don't really need to put it on the screen. And just about every other Gen AI agent operates in that fashion. We go to a website, we're logged in, you get a screen, you type in a question or whatever, and then it like does its thing. And I think that's become normalized already. And I think that's pretty fantastic. You know, in the couple of years that the Gen AI revolution's been kicking in, most of us are at the point now where we're using it pretty regularly. And I'm going to guess that all the people here in the session are probably pretty regular users. All right. So why it gets really exciting, right? When you work with large language models where you can kind of interact with it almost as if it was a human, right? Is it moves us closer to that AGI concept, artificial general intelligence, where, the point is it's becoming more self-aware, right? And really the way I like to think about it is AGI is where it's kind of mimicking humans, and artificial super intelligence is where it will surpass us and probably exterminate us from the planet and all that kind of goofy science fiction stuff. All right, whatever. All right, so let's just kind of move forward here. It says it is growing really fast. And mind you, when they put this slideshow together a couple of years ago, it was just starting to explode at that point in time, and get a lot of public recognition how fast it's really gained prominence. The real trick to it is this auto GPT part that we're still kind of moving towards. And so what does that stand for? Automatic generative pre-training transformer. So the GPT is generative pre-training transformer. So in other words, and think about like even what those words mean. It generates stuff, and before it's trained on it even necessarily, and it transforms it into something. So it must be doing something in the background like we would do as human beings if we're trying to generate content. So for example, if I needed to generate computer code, well, I guess I'd have to learn the code language first and its syntax and how to do certain things, and then some examples of like programs. And then when I have a very specific question and need to write this with my code, I have to go through this whole process of learning to get to the point where I can generate it, right? That's how human does it. Well, because this is technological, it of course happens much, much faster. The self-reinforcing loop and prompts enable language models like GPT-4 to tackle more complicated jobs. And with Finley's input, and I've heard the same thing, that ChatGPT-4 is way better at code generation than the previous models. But I've also heard the feedback that you gave that some language processing is better with some of the older models, probably because the new models are still learning it. And most of the coders, go to the newer models for better coding for obvious reasons, right? The application coordinates and manages work by splitting larger tasks into smaller subtasks. So this is kind of like the part that I was trying to mention before. Like if I give an AI a prompt, right, and maybe I'll just say, hey, can you generate some fictitious Fitbit data, for example, and it does it. And then I look at the data and go, well, that's great, but can you maybe add a few columns to it, and can you generate like 500 more records, that type of thing. Okay, well, now that you've done that, can you write a script that I can put in a Python program that I can use to access it, and and it goes on like that. Where if I can generate the right kind of prompt, right? So I'm going to go back to this again and prompt the AutoGPT, it will figure out all those intermediary steps by itself. And it uses kind of a clever approach to do it, right? So the point of it is, because it can do that, it can take longer, more complicated prompts. And if you're providing additional feedback as it's working, right, and you can usually watch these things work, it will take that real-time feedback and adjust, as opposed to waiting till it's done and then taking the feedback. Interesting thought, right? It says here, Tehran Bruce Richard created it as an open source tool. So here's one of the auto GPT facts is, and for a lot of the AI engines, once again, they use the same libraries, and a lot of those libraries are open source, meaning anybody can build off of them. And that's sparking a revolution right now. So people are sharing their code openly, and then people grab that code and then use it to build other things. And I think that's really kind of groovy. So, all right. So what is it technically then? It says they're recursive AI agents. And I want you to think about this word recursive because it's kind of a term that we usually do to mathematical algorithms that refer to themselves. So recursive means it's kind of like a loop, but it's a self-referring loop. So it'd be like a a loop that basically calls itself, automatically. And so the little clue as to how it works, actually, because those are the kind of algorithms. They're giving a couple of example tools here. So there's AutoGPT, there's Baby AGI, and they use their own results. And I want you to think about this as I say it. They use their own results to generate new prompts and solve problems on their own. So they look at the results and go, "That's pretty good, but you know what? I'm a critical thinker, so I'm going to reprompt myself to go deeper without you intervening." All right. And here's the terminology again: GPT on a loop, right? That's the recursive part. Breaking the user's request into solvable problems and refining each step until the subtask is finished. So if I ask it, for example, build me a website, that kind of thing, like build me the HTML code for a website that does this, this, and that, and has these features and has this kind of look and feel and whatever, it will keep refining those activities until it generates what it needs to. And it's smart enough, like a regular computer programmer, if you will, that when a computer programmer writes a big program, they don't write the whole thing at once. They write a little piece of it. Like, oh, this part opens the file. This part processes the data. This part puts it in a data frame. This part creates the visual. You know what I mean? And they work on each little piece. Now, think about this. If you have a GPT like this that is automatic and recursive, it can look at its own results for each little piece, tweak it, and rerun it as many times as it needs to make it all work together. And I think that's pretty fascinating. So, all right, so they do. So in other words, you give it a master prompt, and then it self-generates more prompts, and it's iterative, so repeating. And what they're saying here is it's this kind of technology. Like, okay, all right, ChatGPT, create artificial general intelligence, go. And then having it like figure that all out on its own. And oh my God, do you think that people have not tried that already? And these are some deep questions, right? And I think that this is really kind of one of the more exciting areas of AI right now. So what we're going to do here, and I'm looking at the clock, and we're going to and I have this tab poised on the other screen, and I refrained from doing anything inside this environment. So what I'm going to ask you guys to do here is we're going to explore this tool called Agent GPT, which is one of these, type of, auto GPTs. And there's a little prompt here. So if you want to just Google Agent GPT, and you'll end up on the website, and I'll bring that screen back over here in a second. And here's the steps, basically. Here's the link. So it's on the slide if you want to click off the slide. And they want you to basically look around the interface a little bit, and then they want you to try a prompt. And I am gonna spool this one up here if I can. And actually I have to go out. You know what? Maybe I won't. But I think it's an interesting prompt. Imagine a world where humans can communicate telepathically, describe a day in the life of an individual with this extraordinary ability. So this is really creative as a prompt, right? So if you guys want to try that prompt, please go for it. When you go into this tool, this is not a free tool, right? I want you to notice here that they have given me uh, 5 runs. That's why I didn't try it at all. I didn't want to waste them. I wanted to make sure I had them here for the studio or, this class session here. Um, they have templates that you can use. There's different settings and whatever. And ideally, they want you to subscribe or log in. So explore that as you will. What they've done here, right, is they have an interface. And one of the first things that you do is you name the thing that you're building. And they have some example ones here. So, for example, they have one called Research GPT, and it says, create a comprehensive report of the Nike company. Okay, whatever. Or Travel GPT, plan a detailed trip to Hawaii. Or Study GPT, create a study plan for History 101 about world events in the 1980s. Okay, all interesting prompts. And so these are pre-built, and you could just run one of these if you wish. So I think that maybe I should try the prompt that we have on the slide. So let me see if I can type that in here. And I'm going to call it telepathic GPT. That's what I'm going to call it. All right, so that's the name. And then we give it a goal. And the goal is imagine a world where humans can communicate and I'm using their wording exactly on purpose because I suspect it's queued up, right? And so I'm going to try this, and let's see what happens as we're doing it. Okay, so here's the runtime, and I'm capturing it as I'm recording here. Okay, so they want us to sign in. Of course, I'm just going to sign in with Google. I choose my school account, and then I can always use my private account later. And of course, we have to agree. And then here comes the run. And I want you to notice what it's doing. It's breaking it down into tasks, and it's generating responses that it's looking at itself, and then it's revising, it's reprompting, right? So it's not just spitting out an answer, okay? And notice what happened. All right, so apparently it ran 5 times. So I burned all my credits at once, and that's what I suspected it would do. And then it stopped. However, if it wanted, right, it would keep going and keep working on this problem until it came up to a satisfactory response. Now, the one that I had been playing with is this one that I also have an account with. And we talked about this one early on. And I am signing in with my school account. And this one, I don't know if this one really gets capped out, but you see, like, I've like prompted it to do other things. But I think it's really kind of interesting because I would maybe ask it the same question and see how it responds. And I'm going to just run it and see, right? So here it is. And then here goes the run. And there is a way here, and I'm trying to remember how to do it, where I can watch it right here. So this is how Manus does it, where I can act like I'm seeing the list of tasks that it created, and I'm watching it do each one of these tasks. And as it completes them, what we're not seeing is the granularity maybe that the other agent was putting out there, but it will show you the output of what it's generating, and right down to like if it's like going to like a search engine, or if it's writing code, or if it's generating language, or if it's reprompting. um, and here it kind of goes, and it's like writing a story here. Hands free. I'm not doing it right. um, and yeah, and I wonder if it'll get to the point where it'll cap out. I don't know, but it is coming. So it's completed 6 of 8 tasks. Uh, all right. So there you go. It created a document. I can also make a website out of this. Like, oh my God, right? But what I'm going to do is I'm actually going to download the document here if I can. Oh, well, there it is. I just downloaded it from here. I'll make it a PDF. And then what I think is interesting is like if we took this and like, okay, here's my homework, teacher. Yeah, I'm teasing, right? But I think I'm going to take a moment to try to read through that a bit later. But like, oh my God, right? Like there it is. I think it's fascinating that it did the granularity of all those steps that we could watch it. I think it gets even more interesting, right? Like where this, what it does here, you can also play it back and see what it did. So like if you ask it a coding question, for example, like, I don't know, take like an assignment from the Python class, create a loop that blah, 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 right? You can just watch it like do all the work. And I think that's really groovy, by the way. All right, let's get back to the PowerPoint here. So please play with these tools. Um, if you have any interesting or weird experiences, let me know. All right, so they tell us how to use it, and I think we kind of figured that out on our own. But they also say that you should experiment with it too. And keep in mind that a lot of the AI engines now have agents like this that are working in the background. And then when we come back here, what we're going to do is we're going to look at TinyML, which is pretty interesting too. But we are taking a 5-minute break. So I'm going to pause the video, mute myself, and we will be back in 5. All right, I did have the recollection, and they didn't include this, of course, in this PowerPoint because it wasn't really around at that time. But big companies such as Google are not ignoring this type of tool either. Google recently put together this tool. I'm just going to bring it up in a different tab, and I'm gathering that most of this is not free. But they have basically agents. I'm going to play the little Google video they have here just to kind of get a flavor for it. And in fact, I might play both of these. These are kind of short. And maybe that'll say enough and I don't need to look elsewhere, but let's just watch the video here really quick. If you guys are noticing what it's doing, it not only is doing some of the stuff that these auto GPTs are doing, but it's also operating applications on your behalf, like opening up Outlook and sending an email. And yeah, that's Google opening a Microsoft product to send an email to show you that it can, and that it accesses your own data. So a pretty fascinating tools.
ChatGPT has I think it has a version of that because a friend uses it to basically delete failed Sora generations.
Nice. Well, I'll tell you what, let's play this other short video here. The music is really relevant, but if you weren't sold enough already, right? Um, I think I was tempted to play like this video here, but I think I'm just going to bypass that. I think we saw enough. But basically, just to point out the fact that Google's got a product out there and others do as well. I'm going to bounce this back to the PowerPoint here, and now we're going to focus our attention on this thing called TinyML, and this is really kind of a fascinating thought. Okay, so the basic point of this, right? It's machine learning that shrinks the deep learning networks to fit on tiny hardware. And basically they're pointing out like how big that is, and it's basically, and I have a credit card here in my hand, so it's about the size of a credit card. And if you guys know where this is kind of pushing us to, it really kind of pushes us into the IoT world, where we have the Internet of Thing type of technologies that are now starting to spin up to run some of these machine learning models, and it really kind of creates something kind of fascinating. We think of this type of technology typically as embedded systems. So like these are maybe little computer systems that are, I don't know, put in a car, to automate braking or lane correction or something like that. What's really kind of cool about it is you can run it on small scale computers. Because it's small scale and the data basically is present on the device, it low latency. These tiny devices don't use a lot of power. They don't use a lot of bandwidth, if any. And the thing that they call it here is inference at edge devices. So edge devices that are at the edge of the network, as opposed to in the core of the cloud, for example. They give a little comparison here how standard consumer CPUs, like our laptops and desktops, use like 65 watts or 85 watts of power. And then if you throw in a GPU, like you have a great graphics card, those will consume 200 to 500 watts of power, right? So GPUs consume a lot more power because they process a lot more, right? In a tiny ML setup, when we're using these little microcomputers, the power consumption's measured in microwatts or milliwatts, like fractions of the power. So very appealing. And it says that's about 1,000 times less power consumption. And it allows TinyML to basically run on devices that are unplugged or running on batteries for sometimes weeks, months, in some cases even years, right? Like a good lithium battery, all while still running machine learning applications, once again, on the edge, as they call it. Advantages, low latency. This is really kind of interesting. Since the model runs on the edge, the data doesn't have to be sent to the server to run what they call inference, and we'll learn what that is in a moment. That reduces the latency of the output. So in other words, it doesn't have to be sent to a server, and then the server stores it, and then you can see the results. That there's going to be a delay if you're doing that. You can pull the data right off the device in some cases, right? So immediate data feedback. Low power consumptions, and the fact that you could maybe run it on batteries and run it for a really long time on batteries is very, very appealing. A lot of advantages of this. low bandwidth. Since we don't have to move the data back and forth all the time, well, the network kind of doesn't matter, you know, and we're not necessarily going to be sending the data all the time, maybe once in a while, but not super relevant, right? Since it's on the edge, right, and the data is not in a server, the only way to compromise the data is to get to the edge device. You know, so it adds a little bit of a layer of privacy to it as well. Now, microcontrollers, and we're thinking of very specific types of devices for these. They have tiny bits of memory, so tiny bits of RAM and tiny bits of storage, right? And maybe aren't always the most ideal things, but things can run on that. But so there's some limitations. But when we start to move to what we think of as, and you hear my Velcro going there because I'm pulling out my Raspberry Pi here and I'm trying to hold it up in front of my body so it shows up in the video. And really, I should probably, put a camera on this. But those of you that know what a Raspberry Pi or Jetson Nano are, and they have some examples, so we'll click on some links in a minute. They are special types of devices that can kind of do that. So like we have microcontrollers, which are little tiny CPUs. And you can see that with forecasting and anomaly detection, image recognition, audio recognition, we can run some machine learning models on those, but with limited capability, right? When we move up to larger machines, and then or servers, then we have significantly more thing. But I want you to notice some of the differences, right? Like we can do this stuff on little computers if the model's tight and small, right? Or if we're not so particular about how good the image recognition is or how good keyword detection is, for example, where if you run it on, high powered machines, you can run more powerful models, basically, is kind of basically the whole point of this. There's really kind of interesting things that happen, so I'll let you guys read that on your own. Let's look at some things that they're already doing with these types of devices. So one thing that we see in manufacturing, right, like especially if there's a robotic workforce or mechanization, we put these types of devices out on the manufacturing floor running models, looking at real-time data. And if they're detecting, let's say, anomalies in the manufacturing robot, they can shut the machine down so something doesn't break, that type of thing. It can, think about this. If we have a little computer that's stopping a machine from breaking before it breaks, well, oh my God, we're saving a bunch of money because it didn't completely break. We were able to fix it before it got expensive to fix. They have an example here. It says Ping Services, an Australian startup, has introduced an IoT device that autonomously monitors wind turbines by magnetically attaching to the outside of the turbine and analyzing the data on the device itself. And of course, if it fails, right, it can alert people regarding issues before they happen. And that's one of the, in industry, a huge thing for sure. In healthcare, they talk about the Solar Scare Mosquito Project uses it to curb the spread of mosquito-borne diseases, as they list here. And what it's doing is it's detecting mosquito breeding condition and agitates water in a pond, for example, to prevent the mosquitoes from breeding. And it does that by running on solar power, and it does so basically indefinitely, right? So if your solar power and there's a battery, we don't need to connect the power. We don't need to hook it to a network, and it can run like a pump, for example, to recirculate the water. In agriculture, they're using it to analyze in real time data from sensors that we have in for example, autonomous greenhouses. And I didn't even realize that was a complete thing, but they have greenhouses where the plants water themselves, the ventilation kicks in, they fertilize themselves, etc. It's like, oh my God, right? A lot of these edge devices can kind of do stuff about that as well. Another thing is this whole smart cities initiative. I think I maybe mentioned to you guys like a year ago, I went to the Smart Cities Conference in Denver, a little bit reluctantly, dragged along with the city of Racine people, but it was still cool, right? But they talk about how these types of devices can be placed all around a traffic network to basically um, monitor traffic or adjust things um, as needed and in real time. Once again, um, I'm not sure exactly how these are probably network systems, but I don't know if you guys have ever noticed when you're at an intersection these days, and it's one that has cameras and sensors and lights and all over the place. If you have like a fire truck or police car go through, they have some sort of a signal transponder in their vehicle that triggers all the lights to go red, right? In every direction, and then it flashes a white light in the intersection in all directions, indicating that they're in emergency mode, right? And that's happened with edge devices kind of like these. All right, so getting into the technical aspects of it, and right here we run into two types of devices. I'm actually going to look at the Raspberry Pi first, and I think I clicked on it. And now I got to look at my browser to see if it actually came up, and I'm not sure that it did, but I can just Google it. And what I'm really trying to do is like show you what the device looks like mostly. If you're not aware of this, a Raspberry Pi, and I have, like I said, I have one in my hand here, and this one happens to be in a case, but it's basically a micro computer, and it's a full blown computer system. And you'll notice here they have a few different models, and you notice depending on how much RAM you have on the device. So now they have Raspberry Pis that have 16 gigabytes of RAM on them, and folks, they're the size of a credit card. And it's a full blown computer system. You can buy them in kits where you get the circuit board, a case, power supply, a cooling fan, a couple of heat sinks, maybe a micro SD card, and all that. And there's other kits that you can buy them and make them into game systems or media boxes or whatever, right? It's a full blown computer system. Okay, so we'll look at a little bit more of that in the PowerPoint. The other device is the Arduino, which is more of like the microcontroller kind of device. So once again, you'll see that this is basically, I want to say maybe slightly smaller than a Raspberry Pi, but roughly the size of a credit card. But you notice it doesn't have all of the same features. So this is a little bit more stripped down. And any connectivity you add to this device, by the way, you have to buy as an add-on. Where with a Raspberry Pi, assuming you can put power on it and put a memory card in it for storage as a hard drive, you can pretty much hook up a keyboard, mouse, and monitor, connect it to your Wi-Fi, Bluetooth to it, hook up your audio, whatever, and do regular computer stuff. And it doesn't cost a lot of money, and they're actually pretty darn powerful for their size. So if you've never tried this stuff, I bought mine's a Raspberry Pi 2. So I got it a long time ago, but I just went to Micro Center in Chicago. They had a big old bin of them, and it was like $20 each or something crazy like that. Later on, I got the power supply in the case. I haven't tinkered with it much lately, but it is one of those types of devices that we're talking about. They're fascinating, and it's really kind of a major growth area. So these two types of devices, the big difference is the Raspberry Pi is a full computer. The Arduino is what we call a microcontroller board. So what they're capable of doing. So I'll let you guys look at this for a second. I think what's really fascinating is either device can be used to do often similar things, but the Arduinos, because they're microcontrollers and they're not full computer systems, you basically have to have a little bit more technical expertise to get one to work. If you were fortunate enough to maybe take the IoT connecting class, maybe some of you did, maybe some of you didn't, you will have played with Arduinos and Raspberry Pis or both, right? If you look at the Raspberry Pi, some of the differences here, it does take a little bit longer setup because you have to set up an operating system. It doesn't come loaded with one. Great for projects. Doesn't really involve buying a lot of special gear. You might already have the gear to need to make it go. Um, Great for coding. It runs as a regular computer system, built-in Ethernet, Wi-Fi, Bluetooth, like a regular computer, basically. All right. Um, Here's a really simple example of how these could be used. And you could take, for example, an Arduino or a Raspberry Pi, hook it up to a circuit board. Here they have basically an LED light and a little capacitor or transistor there. And basically, they have a sensor that detects how much light is in the room and turns on the LED accordingly. And what they're basically saying, this is basically how screen brightness works on a phone automatically. Like if it's, really bright outside, the screen's got to be brighter, right? And if it's really dark, you can turn it down, and you don't need to run it so bright. And how do they do that? Well, with really very simple circuitry. That's kind of the point. Um, in the IoT connecting class, depending on who you took it with, if you took it in person, they actually use little circuit boards and Arduinos and stuff like that and do these projects. And it's kind of fun. Here's a little one where they show, for example, that you can buy sensors that read the pulses off of your finger, and then a little micro display that shows what your beats per minute of your heart rate are, right? Kind of like a smartwatch does, right? And these are off the shelf parts that you can buy, by the way, right? And you can build, like you imagine a device, you can probably build it, right? And look, think of the appeal of this. You can build devices that haven't been built before, kind of interestingly. A Raspberry Pi, when you kind of look at it really close, and this is basically exactly what mine looks like. You can see all the ports that it has. It's got 4 USB, one HDMI, 1/8-inch audio, Ethernet, SD, micro SD card slot, micro USB on this one, maybe a USB-C. And like, wow, right? Very, very cool. And when you think about this, you can run a regular operating system, usually Linux, on this device. And it can operate as a full-blown regular computer system with word processors and web browsers and games and all that, right? And it costs barely anything. Pretty darn cool. Now, one of the things, so you understand like why the TinyML thing is kind of cool, but also its limitation is that there's two different aspects to machine learning. There's the learning part, and then there's the inferencing part, which is basically where it operates on its own. As it's trying to say here is in the learning aspect, we actually need some computational power. So we need to like build the models, run the models, tweak the models, all that stuff, train them, and then hopefully we boil it down, to a model that works. Inferencing, conversely, is basically we have a model that works and we basically load it, right, and then use it, right? So for example, it says if we have a weather predictor with some temperature humidity values to predict whether it will rain or not, and it's not like running these huge like National Weather Service models in this little Raspberry Pi. It's taking a model that's already built with an application and dropping it on the device and just utilizing the model. That's kind of the whole point, right? So TinyML leverages that. So here's kind of the summary of that, right? If you were doing, the training or building of a model, you would either have a computer on site or cloud hosted where you're training, you're feeding your data sets in, you're doing a lot of more data input, the models are revising. It might be like deep learning where it's like doing multiple hidden layers. And then when it's all said and done, you create a trained model. In the inference approach, right, we're not doing any of that training here because it really can't do that, right? It doesn't have the computational power, at least not yet, right? So that's the point they're making in the slide here. But I can take a model that's already trained, inject it into the device, and just utilize it on the fly. Now that's powerful. That's how we do like the traffic lights and a lot of sensors in cars and manufacturing and all those things. Right. Another aspect of machine learning is this thing called machine learning operations. And basically what this is kind of like operational approach, right, to doing machine learning workflows to basically enable people in business or enterprise or organizational environments to develop things and do it more quickly. The concept really here is to kind of automate the whole thing. And just so you know, understand where the terminology for MLOps comes from. In software development, we have this thing that we call DevOps, right? Which is where we take, let's say, a database, and then we write some code, and then we create some screens, and then we build an app around it, and then we package it all up. And that process of putting all that stuff together and deploying it is called DevOps. What ML ops is kind of like the machine learning version of that type of approach. So in other words, now notice all the different steps here, right? Like get your data, label it, version it, do some model building, training, retraining, evaluating, that circular process, create different versions, deploy it, and see how well it works, right? And the actual model part of it is here in the middle, but we do have to go through those steps one way or the other. The concept is how do we apply like this automation process to MLOps? Basically what we do is we make sure we have good data. We keep tracking the model to see if it is breaking down, is it improving. You run experiments on it, trying different data, different algorithms, tuning, etc. And then we also want to keep retraining on fresh data to make sure it's still relevant, and then handling concerns about fairness, adversarial attacks, etc. So the concept here is that ML ops really is kind of a combination of like traditional machine learning, the DevOps approach of deploying apps mostly in the cloud, and then combining it all with data engineering. And it's kind of like the sweet spot in the middle of all those skills. Now, for what we're learning how to do here, you might be positioning yourself ultimately to do jobs like this. And this would be a high demand kind of thing. Notice that it says it restores business interest to the forefront of your machine learning application, and data scientists approach their jobs through the lens of organizational interest with clear goals and benchmarks. Okay, so it's kind of reiterating. Now, what I noticed here, and I noticed this when I was looking at this earlier, is this slide is a repeat of the one that we saw before. And so we already looked at this slide. All right. If you start looking at this stuff in the aspect of a project life cycle and how that kind of works, what they're trying to kind of make the point is the different aspects of a machine learning project. The data scientist part, is this part, right? The training and tuning is the machine learning person, and then putting it out there is the DevOps part of it, right? So that's really kind of the breakdown here. And it shows like how there's a process and techniques and circular, procedures in all of this. And so you can kind of break it down, right? Like each aspect. In the first phase, just ingesting the data, right? And that's kind of a term we use in this field, data ingestion and aggregation, and pulling it all together and figuring out what's good, what's bad, what are we going to use. This is kind of interesting too, because a lot of people are starting to do this where they pull in real-time data, basically streaming it in and analyzing it on the fly. That's kind of fascinating. The exploratory data analysis is where we look at the data initially and try to figure out, okay, this is the EDA thing that we were talking about, and we're looking for things that are obvious. Is there a pattern to this? Is there something wrong with this data? What thoughts do we have about it all, right? And we might even visualize it and label it and all those things. When we get to the point where we're data wrangling, and that is basically pulling the data in, cleaning it up, fixing errors, that kind of thing. And then we start labeling and annotating. So what good is data if you don't know what data it is, right? So you might have to label your columns or describe it, or like what they're saying here is if you get raw data and you can match it up with some pictures or other information, it makes for a better training. We do go into feature engineering, right? And this is all stuff that we've talked about where we look at different parts of the data and break it down and figure out what things are important to look at, what might be essential and what might not be. And then, of course, when we have a data set, we also have to split it. So some will be for training, some for validation and regurgitation, if you will, and then the test data to make sure it's working well. Then we go into model training, right? And this is kind of reviewing the whole process, really, which I like. We always have to select which algorithm works best. Some of that's a matter of experience, and the more experience you get, you'll know, hey, this looks like this kind of problem or that kind of problem. We do have to do the model training, right? So that's a big aspect. Then we validate if the model is good. Does it give us good output? We keep tuning the parameters, recycling, those hidden layers and stuff. Then we test the model to see if it's fully operational and working well. And then we package it. And this is the, where we get to the deployment part of it. But the packaging is basically taking that model and exporting it into a format. And then they're showing you here a precursor to some of the formats that we deploy machine learning models in. And then that can be used ultimately in an application. When we start to deploy it, right, okay, so we have this machine learning model, but, which is like a code thing or a thing that works. And now we got to put it inside of an application. So now you need application developers too, which is why the coding is important. If we build the model into an application and it's part of the application's code, I mean, it's just going to keep working. You can also push it to those edge devices too, like we talked about it. And then finally, we get into these performance monitoring. Like, is it working well? Is it adjusting? And, that's an aspect of it too. There are some advantages, right, to doing this. One of them is really rapid development cycles. So in other words, if you can kind of pull all these tools together and you have all of these at your disposal, and I'm going to say for most of the stuff we're talking about here, this is all going to be cloud-based, right? But if you have the data available and you have the models of different types available, and you have the computational power, right? It'll make it go a lot faster than if you have to build it from scratch. When you pull together these pre-configured pieces, it goes a lot faster, right? And it's a lot easier to benchmark it all. So we can deploy high precision models anywhere, right? With edge devices, especially. We can look at how we're allocating our resources. And then ideally, right, if we have good communication between like our data people and our machine learning people and our DevOps people, we can really push stuff out very quickly. More benefits, easier to govern data and the processes. And the feedback that we get allows us to improve the models, and then automated testing and validation helps to ensure that the model bias is removed, hopefully. There are some challenges. A lot of people are resistant to incorporate this because it's difficult. Basically, it says to rely on models in locations where people used to operate in the past. So if your models are dated, maybe they're not valid, right? For sure. And then you're looking here, it says the assessment and consideration of model risk when implementing that's a challenge as well. Here's one of the problems. There's not a lot of people who know this stuff, right? Why you guys are in school learning it, right? And we're at the introductory phase of that. So it takes people that are well-versed to kind of make this happen on a really effective level. So the impetus then becomes to keep learning and deepening your knowledge. And sometimes people do get attached to certain tools and they're good in the short term, but not necessarily good in the long term. Some really quick examples of MLOps in action, and I'm looking at the clock here, so making sure we end in a reasonable amount of time here. So I'm not going to like talk about all of these examples. I think Netflix one is kind of interesting. They have their own in-house machine learning framework. They call it Metaflow, and it allows them to basically rapidly experiment and train their learning models to manage their data. Um, Interestingly, this tool that they've developed works pretty well with the AWS cloud and their services. They also use another internal tool called Runway, and I think we talked about that one. And it automatically alerts ML teams for stale models in production. So if they have them out there for too long, it'll automatically let them know, hey, this isn't great. Let's revise it. Uber also has models that they use. So they use this machine learning as a service platform called Michelangelo. And it also allows to build stuff at scale. And they use this tool called Manifold, which is a model agnostic visual debugging tool. Interesting. Facebook is really huge on AI development. In fact, there's been a lot of stories lately about how they're snatching up AI talent from other companies because they're planning to go huge on this, by the way. That kind of scares me a little bit as them being Facebook, but whatever. They have a brand new platform called Facebook Learner Flow, and you can see what it does here. Basically, reuses algorithm across products, scaling well to do thousands of concurrent custom experiments and organizing them. It can ingest, and I think this is astounding, trillions of data points daily, train thousands of models either offline or in real time, and then deploy them to the server fleet for live predictions. And let's not forget the piece. This is like automated, right? So how is it they're taking your search algorithms and then reacting to them in real time? This company here, Carbon, uses a tool called Data Robot to create credit risk models. So making decisions about people's credit worthiness automatically. That I think that's a little scary too, but companies do it, right? Let's now start to look at some of the foundational Gen AI models here, and we are folks getting into the home stretch here, so we don't have a lot of slides left, just so you know. All right, so it says enhancing tools to boost development pace of ML models. It says, well, current ML ops players simplify the deployment of internal models. Developers face the challenge when they are building third-party applications on top of them as a service. So they have to figure out how to handle that piece. That's an aspect of this. Another common challenge is fine-tuning models on certain data sets to create a derivative model tailored to the specific use case. So in other words, you might have example models, but they might not work with your data well. So you might have to tweak things to make it work well. Another set of challenges, it says here, the foundational models involve addressing issues such as improving their performance and retraining, ensuring cross-platform compatibility. And what this really mostly addresses is the security and reliability aspect. And because everybody wants to create unique apps and unique products, right? They're all looking to find different ways to collaborate, basically, hopefully sharing responsibility, and what I think is kind of fascinating about this is how open source a lot of the models are and a lot of the tools. It's the processing and handling of the data, especially in the cloud, that is costing us money, right? But the libraries, once again, I'll go back to this thing where it's potential, right, that you can take your own language models and launch them on your own machines and run your own AI natively, right in your own house, right? You can come up with your own HAL or something, right? So something to think about. All right, so these are the things that we looked at tonight, and that caps the PowerPoint. So I'm going to end the video here.